Everyone, today we're going to play a really fun math game. Let's have a small activity first. Come forward, handsome. What's this?
A stapler.
And this is?
A blue pen.
I put them into this bag.
A red pen and a blue pen.
It's time for magic. Now, I want you to draw out the blue pen. You can only choose one bag to draw.
This one.
Why do you choose this one?
The items in the bag felt differently.
Then, feel them by yourself. Wow, she drew out the right one. Isn't she great?
No.
Not really. Try to draw out the blue pen from this bag. She drew out the red pen. If you also draw out the blue pen from this bag, which one do you think would make you happier?
This one. It means I'm lucky.
Lucky. She gets to decide which one to draw out from this bag. Yes. And then, everyone has a wheel on your tables. Today, if I spin once, it could stop at odd numbers or even numbers, right? When spinning twice, it could be 2 odd numbers.
2 even numbers. 1 odd number and 1 even number.
So later, when we spin, do you think the probabilities of 3 outcomes would all be 1/3? This student, she thinks it would. And there are some disagree. It's all good. What we want is to hypothesize boldly and prove carefully, aren't we? Now, we're going to conduct experiments to see if it's reasonable and accurate. Before we play the game, you have your own chess on the table. The outcome you think it would be after spinning twice. Either 2 odd numbers, 2 even numbers, or 1 odd number and 1 even number. Bet in advance. After betting, then we're going to spin the fidget spinner twice. When you get the outcomes, write them down on the recording sheet. Everyone records your own outcomes. If you got the answer wrong, you wouldn't be able to score. In the end, on the recording sheet, how many times in 10 rounds are there? 2 odd numbers, 2 even numbers, or 1 odd number and 1 even number, respectively. And how many points do you get?
It's odd number. Yes, it's odd number. 1 point. Another bet. 1 odd number and 1 even number. It's even number. Awesome. The ones with 2 odd numbers. 1, 2, 3, 4. The ones with 1 odd number and 1 even number. 1, 2.
Why are the outcomes different from your bettings? Bad luck. I don't know.
In every round, the probabilities would differ. And in the 10th round, we were just running out of luck.
I bet on 2 odd numbers. The outcome was 2 even numbers. It was also because of luck, so I didn't.
I bet on because I think the probability of 1 odd number and 1 even number is higher. I was lucky, so I scored.
Moving on. Question 1 to 2.
We all bet on 1 odd number and 1 even number.
You bet on 1 odd number and 1 even number the whole
time?
time?
Just the first and the 10th round.
So did I, but I was wrong on both times.
The probability is the highest. The probability of 1 odd number and 1 even number is half.
In the first round, what was the reason of your betting?
Just guess.
How about the 10th round?
Also guessing.
How many points did you get?
4.
In the first round, what did you bet on?
1 odd number and 1 even number. I think its probability is higher. In the 10th round, it was purely guessing. I think this method has a higher probability of winning.
You bet on 1 odd number and 1 even number. You think the probability is higher, so you bet on that one. What about the 10th round?
I was winning while I was betting. I saw that in the previous rounds the probability of me winning was pretty high, so I just kept winning.
Which made you more certain that it's the right strategy to bet?
That's right.
Our whole class was divided into 12 groups. How many times do you think there would be 2 odd numbers, 2 even numbers, and 1 odd number, 1 even number in 120 rounds, respectively?
I think it would be 40, 40, 40. I also think it would be 40, 40, 40. It could have 4 outcomes. 2 odd, 2 even, 1 odd with 1 even, and 1 even with 1 odd. And then, 1 odd with 1 even is the same as 1 even with 1 odd, right? So, 1 quarter, 1 quarter, 1 quarter. Because 1 odd with 1 even is the same as 1 even with 1 odd, so becomes 2/4. I think it should be 1:1:2.
Me too. I also think it should be 1:1:2. So, it would be 30, 30, 60.
Yes, probably 30, 30, 60.
Because
it would have 2 odd numbers, 2 even numbers, 1 odd number with 1 even number, or 1 even number with 1 odd number.
But don't you have to use your own data to estimate?
I predict
30, 30, 60. No. Wrong.
Why? Because they are not necessarily integral.
31, 37, 52. Exactly 31. 30. Why did you predict it with 30 only one number off?
I think one odd number with one even number is the same as one even number with one odd number, after predicting how many times they could happen. And then I split the rest equally, divided them to 2 odd numbers and 2 even numbers.
One odd number and one even number, whose prediction is the closest to 52?
I predicted 56, because I think the probability for it to be one odd number and one even number is half.
If it's 1/2, then it should be 60. Why did you guess 56?
Because I think there might be a bias.
Or is it because of luck?
The combination of luck and bias.
One odd number and one even number is the most frequent outcome. Reconsider this. A moment ago, did we actually bet on 3 conditions? Is the probability 1/3? Raise your hands if you agreed on 1/3 at the beginning. Do you still agree? Why don't you?
Because that's not what the outcomes told us.
Write down your answers. When you spin once, how many possible outcomes would it be?
It could be either an odd number or an even number.
What are their probabilities?
Each of them is 1/2, because it could only be 2 possible outcomes.
What are the possible outcomes would it be in one round?
One odd with one even, or one even with one odd. They are the same. Is there any difference? There is. If today you spin to an odd number first, and then you spin to an even number afterward, is not the same thing as you spin to an even number first and then spin to an odd number afterward. So, the probabilities of these 4 outcomes are 1/4, 1/4, 1/2. You see, here are 6 possibilities and here are 6 possibilities. 36 conditions, right? And you see it could be circle with circle and circle with circle, circle with circle. So, there are many possibilities. It would have 9 conditions. So, the probability of both to be circle is 9/36. 1/4. Good job. 1/4, 1/4.
When you're done writing, post them on the board. Have 30 seconds to take a look at. If we're going to vote, which group do you find the best? Is it this group or this? This one, or this one? This one, or this one?
We split them into the first spin and the second spin. These are the possible outcomes of the first spin, and these are the possible outcome of the second spin. And then, there are 4 possible outcomes. So, 1/4, 1/4, 1/4, 1/4, and these 2 are the same. So, the probability of one odd number and one even number is 2/4, which equals to 1/2. Starting from one odd number, it could be 2 odd numbers, one odd number with one even number, and then one even number with one odd number, and 2 even numbers, because one odd number with one even number and one even number with one odd number both are one odd number and one even number. So, combine both of them, the probability is 1/2.
There's a wheel on the table, a new one. What's the difference between this one and the one before?
There are 2 more sections of even. There are 1 more section of even. 2 sections of even. There is 1 more section of even and 1 less section of odd.
Question 3-2. What conditions would it be when spin once, and what are the probabilities of each outcome?
It occupies 4 sections, and there are 6 sections in total. So, it's 4/6 because there are 6 sections. An odd number only occupy 2 sections. So, it's 2/6, right?
We also spin twice. What's the probability of having 2 odd number?
1/3 multiplied by 1/3 equals to 1/9. Why is that? Because this one has 6 sections. Another one also has 6 sections. And on this wheel it has 2 odd number. And another wheel also has 2 odd number. So, this way it's 4 odd number. And because it has because here are 6 sections and here are 6 sections. Multiply them together equals to 36. So, 4/36 equals to 1/9.
Let's write down the answers of questions number 1 and 2 of 3-2.
It should be disagree, because if you only spin a few times, the ratio is almost the same. It only would have some small bias. The more times you conduct the experiment, your data would be more accurate.
Question number 1.
Disagree, because there are 3 sections of odd number, and 3 sections of even number on wheel A. On wheel B, there are 2 sections of odd number and 4 sections of even number. The amount of sections of odd number and even number are different.
Is it appropriate to use Wheela to estimate the data frequency of the whole class?
Not really, but it's still possible, right? Yes, I think it should be no. Because odd number and even number don't share the same amount of the sections. So, the data through calculation would also be different.
Let's take a look at question number 3 and 4.
About question number 3, there might be a bias. But if we infer roughly, it could work. Back then, we didn't use calculation on wheel A, but we could also infer the probable ratio, 1:2. But it could be an extreme result like this one. If we calculate roughly, here is 1/2. and then multiplied by 2. So, the data of 10 rounds wouldn't be so accurate.
In that case, I agree on both, because,
okay, what's your reason? It would be more accurate if we conduct experiments, but using calculation without conducting experiments is also fine.
Question number 3.
I agree, because the probability is something you could know based on calculation.
So, is it appropriate to use the data of 10 rounds?
Probably.
Someone starts doubting.
The data from the experiment isn't enough. It could have some extreme value, which makes it not so appropriate.
What about question number 4? Do you agree that someone said it's reasonable to use calculation?
Expressions were also derived from the experiments, which means the probabilities could be known by calculation.
Sort and classify the results and infer expressions from it.
So, it's appropriate to use calculation.
I agree.
actually, I think both methods are fine, whether by playing or by calculation. But using both playing and calculating, the data would be more accurate.
Which one do you prefer?
I think calculation costs less time.
What about actually playing the games?
It could cost more time, and there might be some bias.
Do you agree?
Yes. It works when using the previous calculating methods to infer the probabilities of this wheel.
All the students said they agree, because we just used both methods. You believe we could achieve our goal by calculation. Okay, let's take a review. There are 6 possible outcomes on our wheel. Why in the end we said 1/2, 1/2?
It's probably because in 6 sections, there are 3 sections of odd number and 3 sections of even number, is half.
Then, think about this. Could we simplify the current wheel? Because there are so many.
In 6 sections, there are 2 and 4. So, it's 1/3 and 2/3. That's my assumption. Is that correct?
Is there any chance to simplify like this?
Because there are 3 odd numbers and 3 even numbers. But this one here is 1:2.
So, I classify them into 1:2. In the outcomes of second spin, the ratio is still 1:2. So, I drew it like this.
Let's take a look at question 3 to 5. The probability of wheel B to be 2 even numbers is 1/2 multiplied by 1/2. Wheel B should also be like this. Do you agree?
It should be 1/3, 2/3. It's even number. If we really have to follow that, you see on this type of wheel, there are 6, which means 36 possibilities, right? Yes, 36 possibilities. You see these are even numbers. Each of them could go with another 4 sections of even number. How many is 4 multiplied by 4? 16. Isn't it 16? So, 16 36 is close to 4/9. You get it? That's it. Because based on the diagram she drew, the probability of having 2 even number, isn't it the 1 even number and 1 even number? 1, 2, 3, 4. It's like what I just said. There are 36 outcomes, aren't there? But when it comes to even number, 1 even number could go with another 4 even number. So, that way 4 multiplied by 4 equals 16. 16 36 equals 4/9.
Here comes a tricky one. Please calculate the probability of 1 odd number and 1 even number.
Why do you multiply by 2? Why is it 4/9?
1 odd number with 1 even number, and 1 even number with 1 odd number. Why is it 4/9?
Because it could be 1 even number with 1 odd number or 1 odd number with 1 even number, so it should multiply by 2. Because based on the previous inference, 2 odd numbers is 1/9 and 2 even numbers is 4/9. 1/9 plus 4/9 equals 5/9. And then, 9/9 minus 5/9 equals 4/9. The probability of 1 odd number is 1/3 and 1 even number is 2/3. But 1 odd number with 1 even number is actually the same as 1 even number with 1 odd number. So, multiplied by 2 equals to 2/9 times 2 equals 4/9.
If we play 900 rounds, how many times would it be 1 odd number and 1 even number?
900 times 4 divided by 9 is equal to 400. It would be around 400. You have to add around.
Because it's uncertain, there might be a bias. We could say around 400.
Later, you're going to choose between wheel A and B for me to bet on. If the outcome of spinning twice is the one that I bet on, which means I win. But if the outcome is the other two, which means you win.
The probability for the teacher to win is 1/2. But with another one the probability for the teacher to win is 4/9. Deduct that, right? Otherwise, the teacher must choose
1 odd number and 1 even number.
Because the probability is higher. Using wheel A, the probability of 1 odd number and 1 even number is 1/2. So, the probability for us to win is also 1/2. If he uses wheel B, the probability of 1 odd number and 1 even number is 4/9. So that way the probability for us to win is. Actually, we should choose wheel B, wheel A.
Which one do you suggest the class president to choose, wheel A or B?
Wheel A.
Let's take a look at question number 42. If I bet on the wrong outcome, each of you get 1 point on your prize card. If you collect 100 points, you could exchange for 1 free meal from McDonald's. If you choose wheel A for me to bet on, how many points would you get after 100 rounds? And how many points would you get when using wheel B?
Because what we just calculated was the one the teacher bet on. He could win 90 rounds, and we also win 90 rounds. We still couldn't get 100 points, so it would be impossible for us to have McDonald's. But if he bets on this one and win, using wheel B,
The probability of one odd number and one even number is 4/9. So, he could win 80 times, and we could win 100 times. Then we could get 100 points, so we could exchange for McDonald's. So, the answer is we will choose will be.
Using Roulette to play 100 rounds.
We did the calculation before. The probability for you to have one odd number and one even number is higher. So, I think you would choose the one with the probability of 1/2. So, 180 times 1 divided by 2 is equal to 90. So, 90 represents how many times you would win. So deducted 90 from 180, which are the points we could get.
Then, what if it's will be?
When it comes to will be, it would be 180 times 4/9. It's still the probability of one odd number and one even number. And by using the same calculating method, the answer is 80. 80 also represents how many times you would win. So, 180 minus 80 is equal to 100. That way, we would get 100 points.
So, what's your final decision?
It's will be. Using will A, we would get at least 90 points. If you bet on one odd number and one even number, that way our probability of winning is 1/2. 180 times 1/2 equals to 90. But if you bet on two odd numbers, our probability to win would be deducted 1/4 from 1 equals to 3/4. 180 times 3/4 equals to 135. It could also be applied to will be. If you bet on one odd number and one even number, based on the calculation before, 4/9. 1 minus 4/9 equals to 5/9. So, 180 times 5/9 equals to 100. And then if you bet on two odd numbers, 180 times 1 minus 1/9, which is 160. So, which means at least 100 points.
Which one do you think I would bet on? Will be.
One odd number and one even number.
Is one odd number and one even number the only possibility?
Or it could be two even numbers.
What are the probabilities of having one odd number and one even number or two even numbers?
They're the same.
Under what circumstances would I bet on two odd number?
Wanting us to win.
What if I bet in advance? Class president, just between you and me, I'm letting you know that I will bet on two even numbers later.
Will A. Because the probability for will A to have two even numbers is 1/4, and will B is 4/9, which means with will A, the probability for us to win is 3/4. The probability for us to win using will B is 5/9.
In the beginning, we learned through playing and conducting experiments, and then you all used calculation. When do you think is the right timing to base on theory, and when is suitable to conduct experiments?
Based on theory when you don't have so much time. Conducting experiments when you have enough time.
Not only do we have to consider how much time, we also need to consider how many rounds. If there were too many rounds, there's no way you could finish in time. You would have questions first, so you could assume your answer. That is theory. And then you conduct experiments to verify your answer. When it's under certain rules, it should base on theory. Conducting experiments when it's a subject that has a higher possibility to have bias, in order to infer from. Base on experiments to verify the theory. When the theory is proven, you could use what you proved to calculate. For example, like the odd number and even number earlier. After you matched all the outcomes, you could know the frequency of each outcomes by calculation. It could be found through calculation as well. That is, even if there is no experimental instruments, you could go with calculation.
Think about this. If it's based on theory, what are the methods that can help you think?
List out all the possibilities, and draw a tree diagram based on that.
Afterwards, substitute the values into calculation.
Sometimes it's based on theory, sometimes it's based on experiments. But what's the premise of using theory?
Is it probability?
Probability. Under what kind of circumstances would we have probability that would make our theory exist?
Without any external interference.
Without any external disturbance. In that case, what would we call it? Is it fair?
It's fair.
It's fair, right? We call it under the circumstance of fairness.
Oh.
Which means before using theory, we must know the outcomes are under a free and fair circumstance. Under fair circumstance. Think about it. Isn't today's math class fun?
It's fun. Realizing when the question involves probability, it has a certain pattern. Found out that not everything rely on luck. You could also use your brain to think about it, and you could make the probability higher regarding the outcome you expected.
It's fun. You could conduct experiments to prove probability.
I think it's really fun. Comparing to reading it from the textbook like usual, you can actually feel it. A tree diagram, infer all the possible outcomes.
That's the end of our class. Thank you.
Thank you, teacher.
鸡偶或是偶鸡，只有今天写鸡偶。一样的，有差吗？有啊，你今天先讲到奇数，然后之后再讲到偶数，跟你先讲到偶数再讲到奇数，这合起来是不一样的。我问你哦，你这样子有什么用？
什么情况我也压两鸡？
想让我们赢。
哦。